y'all? Marvin here from Blacktop Banter. Really quick, just wanted to talk about the 800 Pavement Network. As you can see, we have some lettering there, lettering on our other truck over there, lettering on this truck here. They all say 1-800-Blacktop. We've been using the 1-800-Blacktop number here for the last couple years. It's really been exceptional for us as far as making things click with our branding, and now that we're in another state, those area codes are together. It's worked out fantastically for us. The other thing is that 800 Pavement Network has other advantages. There's group discounts on a lot of the products and materials that we use within our industry. We're part of over 300 different, see that one? Over 300 different contractors that are now using these numbers all over the country. That's combined over $2 billion in gross profits. So if you've been thinking about it or you're curious about it and you're like, well, oh, should I or shouldn't I? DM me, message me, or reach out to 800 Pavement Network. You can find them online through their website. You can call 1-800-Pavement and you'll get them as well. They'd be happy to run you through kind of the advantages and everything else that we've been taking advantage of here at Wiscote and Dubuque Asphalt Maintenance, and how it can benefit you as well. Once again, if you're curious about it at all, you can always DM me. So yeah, 1-800-Blacktop. You can DM me or message me or email me through the podcast or Wiscote or wherever as well. I would love to talk to you about how it has helped us. Hey everybody, welcome back. Blacktop Banter. This is episode 83. And I got one of my friends here. Him and I have been able to hang out quite a bit over this last year. It's been a minute though since we've been able to hang out, which I kind of regret a little bit. But my buddy Todd Hendricks is here. Todd is the president of Pioneer Industrial Systems. You guys better know their main thing in our industry as the robotic crack filling machine. Todd, you want to introduce yourself a little bit? I know I kind of knocked it all out of the park there, but there's more to this guy than just a bald head and a beautiful face.
Yeah, man, thanks. I appreciate it. So, my name is Todd Hendricks. I'm president here at Pioneer Industrial Systems. We've been doing robotics and automation for over 24 years now. And a few years ago, we decided to develop a product outside of the industrial market into the road maintenance and repair arena, kind of combining what we know in the factory and taking that expertise to the highway. So it's been a pleasure getting to know you, and yeah, kind of hit that trade circuit hard at the beginning of the year. Then as Tyler and some of the other guys got up to speed, I let them take over, and so I've been missing out on some of these cool trips that they've been on, but I can't wait to hang out at the beginning of next year.
Yeah, I mean, we had a mutual connection through Nicotech, right, to start, and then all of a sudden kind of found out that we're all kind of geeks about this stuff in general, right? So we all kind of were like, oh yeah, like this is the crew. But we got to hang out at MPE last year where I got to see the unit live for the first time in person, and that was kind of like the showstopper, right, dude? It was like right out of the gate. It was at the Sealmaster booth when we were there, and dude, it was just even me, like I was in awe of it when I first saw it, right? And even though I understood already kind of how stuff went, it was the eye catcher, dude, at MPE last year for sure.
Yeah, it was a lot of fun. We weren't sure what to expect. Sealmaster's been a really good partner with us. We're partnering up with them for their extensive experience, but just getting the insights on the ins and outs of the industry that's newer to us. But yeah, we were super pleased with the response at that show. It didn't hurt that we were right up front, right at the entrance. But I can remember before the show opened, seeing the people kind of watching it from the window and pointing to it. And so we were excited for that positive response.
Yeah, and I think that like in its design, for us in our industry, like it's complex when you talk about software and infrared and the way it reads and the way it does everything. But once you understand that all those they're just systems and they're in place, then you are able to look at the machine and see it simplistically, right? Like, well, this is where the air canister is going to come out. This is where our software reads. this is the hot pot that you guys are all used to, and then this is the robotic arm that interacts with the software to get it to read out. But for us in our industry, you know, man, we're sweat, oil, tar, everything, and for us to get some flashy stuff with some software and some robotics and some futuristic stuff was a great kickoff. One thing about you know, when that machine was there and kind of caught the attention of it, of everybody, was the kind of firestorm that lit up, right? We started sharing stuff on Blacktop Banter and everybody started sharing stuff, and then they're like, all right, we really want to know more about this thing. Which it's the RMV, right? The robotic maintenance vehicles. That's the company. Is there a specific name for the crack filling rig?
No, not right now. We kind of refer to it as the RMV.
Yep.
My big vision, though, is to turn RMV into a platform so we can do a lot of different things with the robot on the back of a truck, trailer, or like self-driven unit. So I'm thinking eventually, yeah, it'll be the robotic crack sealer, and that's that product. And then we'd have, you know, a handful of other products underneath that same idea.
Yeah, I know you and I were able to spend some time after the show on different nights, and like just our brains were just like, oh man, yeah, like you could do this. Oh yeah, you could do that. One thing I wanted to ask you about when it comes to that is the thought process, right? You're like, hey, you know, we decided to build one into the asphalt maintenance, you know, one of our robots, we took it and put it in the asphalt maintenance industry. How'd that come about?
No, that's a great question. So I have about a 50-minute commute, and I'm lucky enough I get to work with my dad, and he lives nearby. So a lot of times we'll drive out together. And one day we were driving down the Ohio Turnpike, 8090 on the north side of Ohio, and we passed a crack sealing crew. And this was a big one. There was 12 people, 7 vehicles, and one person with the wand in their hand. And a lot of them were safety because you're on the turnpike at 70-mile-an-hour speed zones. And we got talking like, man, there's a lot of people with just the one guy working, which I know the other guys are working too. But
Right.
we got talking about how inefficient that was. And then we're like, you know, all the requirements with the safety, like it's super dangerous. We drive that all the time. I see people on their phones at least a third of the time. You know, you still have semis going by at 70 mile an hour. That's the last place I'd want to be, is between a sealant truck and a 70-mile-an-hour semi.
Yeah.
And so we got talking through that. Didn't think much of it. Got to the shop. We were doing another robotic project for a tire company, putting sealant inside of a tire, using lasers to measure it, doing that whole thing. And so Dad comes into my office with a sketch. We still have it. And he's like, I got an idea. Everything we need to solve this problem's out there. I'm like, what are you talking about? He's like, look, it's this. And he showed me this rough sketch of the first concept. And this was like October of 2019. And in my infinite wisdom, I'm like, that's the dumbest thing I've ever heard. Get out of here. We have more important things to worry about, you know. And so he just kind of stuck it on his bulletin board and thought about it. And as we approached COVID, you know, our work started to slow down, but we wanted to keep people going. And so we worked from home, and that was our project when Ohio shut down. Was, okay, hey, let's assign this out. Let's design and develop this. We don't know what's going to happen, but it seems to be a really good idea. Dad got to meet someone that works for ODOT at a church event, and kind of pitched it to them, and they loved it and was going to serve it up. And so we thought, well, maybe this does have some legs. And we got through designing it. We had the demo built probably by June. It was a pretty quick turnaround for us to knock it out, throw it together. Kind of got ahead of ourselves on the crack sealing, so we played around moving cones around and stuff. And then once the software caught up, then we decided, no, we want one product to be in development at a time. Once it gets to market, can start bringing in revenue, then we'll develop the next thing. But really the biggest idea was take the people out of the dangerous situation of being on that road, right? And so if I can take that road worker, put him in the cab or on the bed, out of harm's way, getting struck by a vehicle, that's huge. When we looked up the numbers to support the business case, I was just floored by the number of work zone accidents. And
it's out there.
Yeah, I mean, you guys go through this day in and day out. It's insane. So we were just looking at that, and then combined with the fact that everyone's struggling to find people to work. You know, we did a study, the workforce is just too small, and we're all feeling that. So not like we're trying to get rid of jobs. We get to do this job with less. That means contractors can spread their crews out a bit more and get more work done with the same amount of people, or, be able to take those jobs instead of turning them down because they don't have enough guys to fill it. That's some of the stuff that we're looking at.
When we talk about the machine, those are the big glaring benefits, right, that we see. It was like, I mean, this people's families, right, that we're talking about taking out of harm's way. But you and I also would talk about a lot of things like, the robot is a lot more, in my opinion, is more efficient when we get a readout and we're able to not worry about wasted material in a sense, and we're not worried about whether we're going to miss this one or that one. Can you kind of give us a quick synopsis of how the machine works? I know if anybody's never seen it, it's a huge flatbed truck with a Crack Pro right on the back of it. And then in general, though, tell us about how the truck works, what all the components, I mean, not every single bit, but the components of how the machine does what it does.
Yeah, for sure. So like you said, it starts with the truck. We mount everything to the back of the truck, keep it nice and simple. The driver in the cab has a light, and once you put it in crack sealing mode, that light goes green when you creep forward, and then when it's red, you need to stop, let the robot catch up, and that's it. That's all the driver does, is keep it straight and keep it real slow and steady. As the truck goes down the road, there's a blow off underneath it that's connected to a electric high speed blower. So we're blowing off that whole 12 foot of roadway, and then we angle it so that all that dirt and debris kind of gets out of the way to the ditch. So that is happening while the truck's moving down the road. Does a really good job. We use the nozzles over the blades because we did a bunch of testing on it, and that seemed to work the best. Above that, there's the generator. That's where all the power is made to power the robot, the fan, the sealing unit. That's connected to a custom Crack Pro. We customized it because we didn't need another generator. We're just pulling power off of it. So all of our motors are electric. It gives us some more control to connect to the robot and the software, as well as is just a little bit easier and less messy than the hydraulics and stuff. Same with the fuel tank. We pull everything off the fuel tank on the truck. So we just have one thing to fill up. You've got one fuel gauge to watch, just kind of eliminating some of those redundancies. So that's what makes it custom. Heated hose comes out to the robot. Underneath the robot on the back of the truck, there's like this big, we call it a vision shroud, but basically it's this big box that we can expand out to control the lighting. Anytime you have vision applications with robotics and automation, lighting is 90% of the battle, because all vision is contrast. Well, when you're looking for cracks, you're looking for black on black, gray on gray. There's not a lot of contrast there. So by controlling the lighting and then adding in lasers, it helps us really get that map, get that measurement. So as the truck goes, it's scanning these little segments, passing them back, doing the math. Is this a crack? Is it not? Where's it start? Where's it stop? It turns all that into a mapped point, puts it into the robot coordinates. The robot knows exactly where to go. It doesn't have to be stopped. You could be moving, and those points will move in space with the truck, so that the robot's always going to stay on that crack as the truck moves down the road. And then, like I said, if we get out of the work zone, or we're going too fast that we're not going to hit all the points, it'll flash the red light. Truck can stop, let that robot arm finish up that segment, and then we'll move on. So the whole thing's designed to be super easy to operate. From your standpoint, like you said, you guys are just hardworking dudes, and we don't want a lot of complex controls. There's just easy touchscreen in the cab. Really just like a few buttons to hit, put it in auto mode, and just drive down the road.
I know I asked you this question when we were there. Can the robot and the software be adjusted for different widths of cracks, and then also the application rate, right? Like, does that get adjusted, or does the software automatically speed or increase or decrease the amount that the pump is putting out?
Oh, for sure. So yes, we are measuring every single crack. We have the ability to input variables, or the driver has the ability to input variables as he goes to start the system. So you can say, well, my minimum is a 1/4 inch, or no, I want to do 3/8 or down to 3/16. It allows you to select what that min and max threshold is. And so you can fill everything from 1/4 inch to 1 inch, or say I want to go down and up, whatever that looks like. And that kind of goes to the point you mentioned earlier. It saves a little bit of material because we're just using math to determine, do I fill this crack or not?
Right.
Haven't done it nearly as much as your listeners, but having done this before, as we were developing it, it's like everything looks like a crack, man. If there's any type of crack on the road, I'm gonna fill it because I don't want to miss anything.
Right.
And so, my idea of what a 1/4 inch looks like is going to be different than the next guy and the next guy. Where the robot, it doesn't matter who's driving or what. It's just a math problem. Does it measure the size or not?
Right.
So that's what happens there. And then as far as the material flow, the pump speeds and everything, having those on an electric motor and a controlled drive gives us the ability to crank that up and crank that down on a whim. And so, yes, we change the application rate based on the size of the crack, and that's all part of the software. Now there is like some universal buttons that can pump the whole thing up or pump the whole thing down, depending on how things are going that day. But ultimately, it's the software that's determining, okay, this is a big crack, so I need to pump faster so that I can make sure I have enough material to fill it. Or, okay, this is on the bottom of my criteria zone, so I need to slow the pump speed down so that I'm not putting too much material out there.
I got you. So one of the questions that somebody had, we had one of the listeners, like we said we were going to have you on, and we got a few questions, but the main one of the good ones that we both kind of picked out was Steve Demo. He was asking if the road had already been serviced, right, and there was crack filler there. How does it read that, right? Or if the crack filler has cracked open or something like that, how does the robot read that, and what does it do in that scenario?
Yeah, that's a great question. And so, yes, it does. Basically, the scanning, the cameras, they're going to find that twofold. One, the laser is really what differentiates that. So we're looking for depth. If there's no negative value in that measurement to say, yeah, this crack goes down, even though the camera saw that there was something there, it's a little bit different. There's no negative crack value to say, yeah, fill that up. So it's going to completely ignore it and just keep going right on down. Now, if that crack has opened up and there's a new crack inside what had already been filled, it'll go over it because it saw and measured that there was a crack, as long as it's within that parameters like we talked about. And so that's one piece. The other piece is we have implemented AI as we go through the process of training the truck on how to find cracks, how to find cracks that continue throughout the work zone, to recognize alligator cracking so that we can avoid those areas and mark them. Potholes, same thing. We avoid potholes so that we don't damage the tool. We're not swinging through that work zone on the ground with it and damaging stuff.
Yeah.
And then also things you shouldn't seal, like manhole covers, storm grates, those types of things. So the AI also has some really cool stuff to recognize this has been sealed before. There's no crack in it, just ignore it. Or it's been sealed, but we're measuring there's a crack there, so hit it again.
That's what I was wondering. I was going to ask you about the potholes. Like if there's a void like this big, like let's just an 8-inch void, it completely just skips that. It's like, no, this is way too much.
Yeah, and we put some avoidance software in there too. So the way that it runs is we just keep the puck on the ground, much like when a manual crew goes down, you just drag it to wherever you go. Why do all that extra effort?
Correct.
The robot can lift up and go down all day. It doesn't get tired, but it wastes time, and we don't want to waste time. So we just keep it on the ground, slide it from point A to point B, and then turn the pump on again.
Okay.
And so, we need to recognize, don't just fill it up with sealant because that's a waste. That's not going to fix it. And so we're trained not to do that. But then B, we also train the system to not run that puck through the pothole to risk damaging it. That robot will pick up 450 pounds all day. So it'll clearly bend that end of arm tool that we have on there. So we want to go around that pothole so we don't smash it. But one thing we also threw in the background, and that we're still working out the kinks, but it's there, it works. We can GPS coordinate when we see a pothole.
Oh, okay.
So as we're working, we're measuring in the background how many feet you're doing, all those details. And then we can also earmark and say, okay, well, we found 3 potholes on this stretch, and they're at these GPS coordinates.
Oh, okay.
We found alligator cracking at this GPS coordinates, and we ignored it, but what that's doing is it's giving, your end customer, whether it's a city, a state, municipality, whatever, hey, here's some preventative maintenance that you could do in these 3 locations.
Yeah.
Before they get worse and people start calling and complaining, you can be proactive instead of reactive. And that seems to be a pretty feature that has people pretty excited.
Yeah, I mean, that's a valuable piece of data. You know what I mean? Because otherwise you got somebody out there going manually and saying, well, this is a spot, well, this is a spot, well, this spot. You completely eliminate that if the robot's going back and forth right on each side.
Yep. So that was kind of our thinking is, well, if we're going to go to the trouble of recognizing it to, not fill it and to avoid it, well, we might as well just GPS tag it and share that data. And so that's one of the data pieces that we're excited about. The other one is just collecting the data on the roads. So when you're done, you can see how many feet of material or how many feet of cracks that we sealed, from when that pump turned on to when it turned off, what fell within that criteria range. So we're tracking all that. So we can track linear distance of the truck, number of feet sealed, any potholes, any alligator cracking.
Dude, it's way more than just filling cracks.
Yeah, it's doing some cool stuff.
Yeah, like it's doing cool stuff, dude. Like besides just filling cracks. And at the surface, when people see that, they're like, oh, that's badass. That's filling cracks. So then you realize all the data you can get and all the information you're going to get. You'll be able to compare, right? Like over, let's say they do another crack sealing run in 10 years, 5 years. They would be able to compare if they just ran it over it and be like, oh, well, this is the percentage of increase we had over X amount of time, right? With doing whatever. So maybe we can prepare in the next 5 years to allocate X amount of dollars to it. And let's kind of talk about that a little bit, right? The dollars and the cost and everything else, because I know that question is going to come up. Where is first of all, we'll talk about where the machine is getting put to use quite a bit, because I love the Air Force Base footage myself and stuff when we get out there. Where is the machines being used? I think the last time you were telling me there was 3, right? Or something like that. We had 3 in order, or
so we're working through a few pre-orders now. We are negotiating, I think, 15 different deals.
Cool.
With people all across the country. The truck's been all over. I think we've hit 34 different demos and trade shows this year. Going to have another blistering schedule next year, but basically, dollars and cents. There's 2 different ways, which is a little unique to get in the truck. One, you can just buy it outright. It's an expensive piece of equipment, but when we run the ROI, it pays for itself typically in 2 years or so, typically less. But the purchase price is $1,050,000. Or there's a lease option. So you can get into it for much cheaper. It's a 7-year lease and you pay us per foot of crack sealed. So every foot is 5.5 cents. And as you go down the road and seal, we tally that up in the background, invoice it out monthly. There's some annual minimums to hit over that 7 years, but at the end of the day, it lets you get in it, pay it as you use it. And then, because we understood, okay, $1 million is a lot. How do we look at doing that? We're doing some things now design wise to try to pull some cost out to be more effective with some of the components and materials and everything that we're doing, as well as the efficiency of building these for more than the first time or second time. So after we get those under our belt, I think we'll be able to push that down in the near future, under that $1 million mark, but that's where it's at right now.
But the lease program is fantastic. Like that's the way in. Like for me, anyways, with the contractor mindset, and all my friends and listeners across the country, like there's guys I know that like were like, and then when we mentioned the lease program, they're like, oh, all right, yeah, tell me about that now. And I think that's one of the major things.
And that's one of the things that I was kind of surprised about, was just how varied the business process is around people getting crack sealing, contracted out. Some people pay by the whole lane mile. Well, if it's good, it's this much. If it's bad, it's more. Some people pay by the pound. And some people pay, well, how are you going to calculate the number of feet unless you really go out and measure it? And that's a really hard task to do right now. And so this is hopefully a way that we can kind of all universally come together and say, okay, I'm just going to do it in feet, and this is fair. And, I did X feet, so pay me for X feet, and everyone's happy. So I think that's one thing that's really exciting to come out of all this is hopefully getting that figured out.
Yeah, I mean, that makes it easy, especially if you're going to use the RMV, right? And you're like, well, it's going to cost me X amount. No matter how many feet I do, it's going to cost me X amount per foot material wise. And then to do X amount of feet, the machine has to run this long, right? Most of the time, you know,
Yep.
so I have a driver, I have the fuel, I have the time, and the machine has to run this amount of time to run this many feet. It literally makes job costing it like a dream compared to how we do it, where we're like, well, we're going to measure a certain section and then times that by 10 and hope
And
that
hope it's right.
that hope that equals out, right? Yeah, and hope that my arms aren't so tired at the end that I'm just pumping like a son of a gun.
Yep.
So with all that entail, right, and you know, the machines on order and where they're going and what they're doing, what does the future hold then? What does the future look like for RMV? I know, you know, we've had some great ideas and some great brainstorming, and even I don't like to come up with, you know, tell some of the great ideas that I've come up with brainstorming wise, but I don't, without letting you let too much out of the bag. It's the first thing, in my opinion, at least. I'll speak for myself, but it's the first thing in my industry in a long time that I've been this excited about, and I'm still excited about the machine because it made us leap from here to here like tremendously. And I'm like, all right, finally, now let's somebody else follow along and start doing some more of this stuff. What does it look like? What does the future look like for RMV in the outlook?
Yeah, so we're finishing up development right now. We're working through those first few orders, like I said, and we're going to get out of what we call beta phase, hopefully by the end of the year, if not first quarter, to where we're done with the development. After this, it's just software upgrades with bug fixes and that kind of thing. For us personally, the big thing next will be twofold. One, we're building another facility right beside our current facility. The industrial side of the business is going like crazy too, because it's just hard to hire, man. So robots are a good fix for that. And so a new facility, getting some dedicated space to build out these RMVs will be helpful. It'll be more efficient, like I talked about earlier, to help us drive that price down for the end user. So that's one thing, is getting that facility up and going. We're finalizing plans, and hopefully as soon as ground breaks this spring, we'll knock that out. The other piece is service. And so we've got some great people on our team. The first few units that we're looking at are not local, so we know that we're going to have some issues pop up. And that's one thing we want people to be comfortable with when we're talking through it, is it's like, look, we have the ability to dial into this machine. We put a 4G cell card on it. I can connect to the machine. I can see what the robot sees. I can see what the PLC is telling me. Like, I can dial into all this stuff. And so our big thing is going to be building up that service and support team to where we're continually providing top-notch service regardless of how many trucks we get out on the road. So that if people have issues, they can call us. We can talk them through it. We can dial in and fix things, get them back to where they're running as fast as possible, because we know that's super important. So the service and the additional building will be kind of on the operational side. On the new product side, I think our next really big investment, we've got two things that we're digging into now. One is the cones. We keep getting a lot of feedback there that this would be really handy. It's really dangerous, whatever the case may be for the need. Picking up cones, grabber cones, barrels, putting them down, picking them up, even if they're falling over within the work zone. So that's probably the next one we'll get to. We were pretty close once the crack sealing kind of took off, and so we shelved it, but I think that'll be exciting to get launched. And then the other one, we're still working through the patent with that one, but it's an exciting product. It's basically, we call it the modular traffic rover, and we're taking out more technology from industrial world, distribution world, automated guided vehicles. So these little, there's a campus near us, BGSU, and you see them in the news all the time. They deliver food with these little robots on wheels, and they go all over the place by themselves, right? Well, instead of people being out there with the signs as the first line of defense, could we automate that with a robot to where if it gets hit, but no one's hurt? And then the also thought is, well, with these trucks, I can move the work zone.
Oh,
I don't need
okay.
anyone out on the road. Well, why do I need my flaggers out on the road if I can make these automated signs move with the trucks?
Right.
That provides a lot of value. It provides a lot of safety. You can still have, big signs, big flashing lights, video, all that type of thing.
Yep.
That's a little bit even more than what's offered out there now with just a person with a radio and a sign. And so that's another thing that we're looking to develop into next year, but it's just getting started. So I wouldn't expect to see a launch or anything yet, but
Yeah.
it's going to be in the R&D queue and
It's
getting
cool,
through
man.
our engineers.
Dude, it's just downright cool. Like to have something there that even sparks your mind to be able to think about what's possible in all these other forms, right? Whether it's the
Mhm.
the cones or the rovers or any of that kind of vehicle. It's totally cool. I know you might not have this in front of you, but what are some? We have some big shows coming up. MPE is gonna be coming up in Charlotte. I know you guys were there last year, and then ConAg is coming up again in Vegas. Is it gonna be at any of those shows, or do you have any big shows on tab that people could stop in and take a look?
Yeah, it'll definitely be at ConAg in Vegas.
Sweet.
We're working together to finalize that now. On our website, we do have a demo calendar so that you can see where the truck's going to be
Cool.
coming up, and we're making sure that we get that published, get that out there. But I definitely know that ConAg's on the list.
Sweet.
As far as the NP and some of those other ones, I'm not 100% sure. Like I said, I know our team's still working through that. And
Yeah.
then we're also looking to maximize the time when we're on the road. And we kind of did that this year. Anytime we'd go to a show, we'd try to set up demos with, the local Sealmaster franchise, the local ODOT or INDOT or whatever DOT statewide function that was. And so as we went through the country on this tour, we'd hit these smaller stops and bring people together, actually see the truck on the road, laying the sealant down so that you knew it wasn't just us hoping that this worked in a booth.
Yeah.
Out there working.
Well, that's the other thing is too, you guys do a really good job on social media. I know on Instagram, TikTok, like everywhere, whenever I post anything of RMV, I'm able to tag you guys. So if any of the listeners or followers or anything like that, they can definitely check you guys out on there. You type in robotic maintenance vehicle anywhere, you're going to find it, man, because it's definitely there. I have one personal question about the machine, and I've never, I mean, not personal, like personal, but personally, I am curious about when is there going to be a robotic person loading the rubber into the machine?
Oh, that's a great question. We've talked about that because I think that's another piece that definitely takes the danger aspect down, is if you have someone on the back or
It's
having to
just
park
hot,
and get
bro.
out.
It's just hot. I just
Oh, it
don't.
is. Yeah.
Dude, I just don't want to be up there by it, tossing it.
Yeah. So we've looked at other ways of like trying to automate that to where you can, do like a magazine of 5 or a conveyor of 10.
Yeah, I knew you were
going
gonna say that, dude. I knew you were gonna say that. Yeah.
Yeah. And we looked at, yeah, we could slap a robot back there, but there's some cheaper ways of doing it. I
You
think
just push a button, right, and drop a block in.
Yep. Or every so often, based on how much I put out, I know that I got to drop another one. Yeah, we got some things that we're
that'd be
working
so
on.
great to find that sweet spot, Todd.
Yep.
Oh man, dude, if you could find that sweet spot of we put this much out, we can put this much in, and it'll keep up, and we just have continuous rubber all the time.
Yep.
Oh man. Oh, what a dream. That's heaven. What we call that in asphalt maintenance world is heaven. Well, my friend, any other insight or anything you want to spit out before we go? I mean, dude, it's been way too long for you and I get to hang out and brainstorm and go all there, and you guys are just killing it. And I'm missing it having to do all my stuff over here. I'm very excited to catch up with y'all and do it. But what about any other thing, any other insight, anything that you might want us to know?
Yeah, so I'd say one of the things that I notice as we post out and engage with the social media community, the speed is always a comment, right? Oh, that's so slow. I'm so fast.
Yeah.
When we do measurements and we do some side-by-side tests and whatnot, it's pretty comparable to a manual crew in the fact that it's typically faster. And over time, I think the big thing is you don't have to stop and take a break or stop and switch out drivers or
Correct.
You know what I mean? Oh, I mean, if you're going to be super slim and you got to stop and throw blocks in and do all this stuff, it doesn't take long to really add up to those little itty bitty stops that the manual crew is going to make over time. Yep. You don't even think about during your day. It's just, I got to get a drink of water. Hold on, man. Well, you can drive down the road and eat a cheeseburger in this thing, and it's not stopping working. And so that's the one thing that I would just challenge is, okay, I get you could have a manual crew that just bust their butt, and yeah, they're flying. But
Mhm.
this crew, this one truck can do it with one guy, and then take those 3 guys that were on your crew, split them over 3 shifts,
That's
and
what I was
then
just
talk
gonna
to me
say.
at the end of the week.
Yep.
So that's one of the balances. It looks kind of slow in the demos when you're seeing it, and it's like, oh man, you don't go very far. But when you're doing it manually and you stop after 10 minutes, it's like,
Yeah.
that's how the farther we went. So I just throw that out there to your listeners. I get it. It doesn't look super fast, but we're chugging along like the tortoise and the hare, and we're just slow and steady.
Yeah, yeah, and that's like the point I was gonna make, where you're like, well, take those other 3 guys and go put them somewhere else. Like that guy wants to prove how fast he is. Go up to mile marker 10, then let this thing do it. You go ahead and take the old Craftco or the old Crack Pro or whatever else we got out here doing it. I mean, dude, you get an hour and a half in on the wand, and you're like, kill me.
Well, it's hard
Some
work.
days out there, dude, in the heat, especially ours. We got an older one. So here at West Coast with no heated wand. So the guys are like, oh, yeah, we just wait till one day. I try to like hold them out as long as I can with the archaic stuff before we get into the good stuff, because then otherwise I feel like they're spoiled, right? Like they haven't paid their dues. Like no one on staff has had to manually mix a seal coat tank. Like no one has had to do that. And dude, that used to be the worst part of the day, right? Is you get out there and mix that thing by hand. And now they're like, the stuff they complain about, sometimes you're just like, man, you have no idea how it used to be. And I think about that with the RMV, right? That these guys that, at some point, both of our sons are the same age, right? So my son's going to be like, one day I'm going to just be in the cab with him in the truck. And we're going to be dropping chunks of rubber in at the push of a button. He's going to be like, oh, and I'm going to be like, kid, you have no idea, dude, what it was like. Well, my friend, once again, looking forward to seeing you here coming up. Thanks for joining us. I know it's been a long time coming. We've been wanting to do this. One thing that I really like about Pioneer and RMV is the family feeling that we have there with the whole team, with you guys. When I see it, tell your dad I said hey, and hopefully I get to see the family and everybody here sometime soon. And I'm going to try to get out there. I wanted to get out for the open house. I didn't get to make it. We were just in the heat of the battle out here, but next time I'm definitely going to try to make a double effort.
Yep, we got another open house at the end of July next year, but anytime you want to come on through, let me know. I know summer can be kind of busy for you guys, but we love to show people around and share what we do.
Cool. All righty. Well, thanks again, my friend. For myself and for Todd Hendricks Jr., this is BB83, episode 83. And like always, here at Blacktop Banter, we speak asphalt. Thanks.